In session 14 here, we're going to take a look at direct variations. Direct variations are just special types of functions, which we discussed a little bit earlier in a previous session. What I'm going to do is reintroduce the same example that we used on a previous lesson to illustrate what a direct variation is. Here's the example. To encourage his daughter to save money, the father said that for every dollar that the daughter deposited into her bank account, he would deposit $3 into her account on top of what she already deposited. So to write down the function of what's going on here, there's a relationship. The amount of money that the father deposits into the bank is dependent upon or relies upon the amount of money that the daughter is going to deposit into her bank account. So there's a relationship between the two. There's a function. His deposit is a function of the amount of her deposit. So here's the formula. F, which stands for the father's deposit money, is going to equal 3 times D, where D equals the amount of money that the daughter is depositing. So over here is just a quick table that lists 5 different values of amounts of money that the daughter deposits, along with the corresponding amounts that the father would then deposit. So when the daughter deposits $0, so does the father. And that's the F row here standing for the father. The D row standing for the daughter's deposit. If she were to deposit $1, he's going to deposit 3. Why? Because if we stick 1 for D into our formula here, 3 times 1 is 3, and F would then represent 3 when D is 1. When D is 2, we put the 2 into the formula here. We get 3 times 2 is 6, so that when she deposits 2, he deposits 6. When she deposits 3, he deposits 9. When she deposits 4, he deposits 12. So taking a quick look at this, you can see that there's a relationship between the F amount and the D amount. And the relationship is that the F amount is going to be 3 times the amount of the corresponding D value. If the daughter gives $1, he deposits 3. Well, let's say that the amount that she deposits doubles. It goes from 1 to 2. What then happens to the amount that he deposits? It also doubles. It goes from 3 to 6. Start back here at our 1 again. Let's say she gives $1, which means he gives 3. Let's say the next week she triples the amount that she gives. So she's now going to be giving 3. Well, when the amount that she gives triples, what happens to the amount that her father gives? Well, it also triples as well. That's what a direct variation is. There's some multiplier that's going to be multiplied by the one variable to give you the result of the other. So generally speaking, your direct variation is going to have a formula in this format. Y equals A times X. Just as brief explanation, both the X and the Y here are the two variables. And remember, variables mean that the values vary. A is going to represent some constant number that within this formula itself never changes. So let's back up here and take a look at our original formula here, our original function. In this function up here, we're not using the letters Y and X. We're using the letters F and D. But that's still okay. All the letters Y and X indicate is that you have 2 different variables going on. Well, in this function up here, we have 2 different variables occurring at the same time. D, which represents the amount that the daughter's giving, it varies depending on how many dollars she gives. And F, that also varies. That also depends upon the amount that the daughter gives. But within this function itself, within this formula, which number never changes? Well, this 3 never changes. Doesn't matter what D and F are in this formula, the number 3 never changes. It always remains the same within this particular formula. That's the A value down here. That's what we mean by a constant. A is going to represent a constant number that stays the same within the formula itself. It never varies, as do the variables. So let's just pick a couple of formulas off the top of our head, and we'll see if they are direct variations or not. Here's y equals 6x. Remember, our direct variation has to have the format y equals ax. Well, do we have two variables here? Two different variables in this? Yes, we do. We have an x and a y. And do we have a constant? A number that will remain the same within this particular formula itself? Yes, we do. We have a 6. Y equals 6x is a direct variation. How about y equals 4c? Once again, we don't have to have the variables x and y in order to have a function. We just have to have two different variables within the same equation. Well, here are the two variables, y and c. So that part is met of our definition. And then also, do we have a constant number that remains the same within the function or within the formula itself? Yes, we do. We have a 4. Y equals 4c is also a direct variation. Okay, now, on our second screen here, what we're going to look at is actually graphing a direct variation. We have the same formula from our previous screen, f equals 3d, and here's the same chart. When d is 0, f is 0, d is 1, f is 3, and so on. So we have 5 different values that we can now plot on this graph. The first one that we're going to take is at the left of the chart. When d is 0, what's f? Well, in this particular case here, in order to not cause so much confusion, I'm going to go ahead and change this to x's and y's. And the reason why I'm going to do that is because in our coordinate graph, at this point here, it would perhaps be confusing to have a d going on one part of the graph and an f on another. We're familiar with the x's and y's, so that's what I'm going to do. I'm going to go ahead and change this formula into an x using x's and y's. So I'm going to change the f to a y, and I'm going to change the d to an x. Okay, with that said, we're going to now come up here and replace our values here as well. The f here got replaced with the y, and the d gets replaced with an x. So now, our function is now y equals 3x. When x is 0, y is 0. When x is 1, y is 3. When x is 2, y is 6. So let's go ahead and graph this. When x is 0, our y coordinate is also 0. So there's our first point right there at the origin. And as a reminder, the x-axis goes horizontally or across your page, and your y-axis goes up and down or vertically. So we've taken care of the first point, 0, 0. Our second point that's going to be an answer to this particular equation here that we're going to plot is x equals 1, y equals 3. So we're going to count over on our x-axis 1 away. There's our first. Then we're going to go up 3. 1, 2, 3. So there's our second point. This point has the coordinates 1, 3. Our next point has the coordinates 2, 6. So start at our origin, go over 2, and up 6. So there's the next point. That takes care of that one. Okay, when x is 3, y is 9. So go down, start at the origin, go over 3. That's our x value, and then up 9. And there is our next point. And then for our final point, x is 4. Count over 4 from the origin, and then up 12. 9, 10, 11, 12. So at this point now, we have gone ahead and graphed the points on this function. Now the function actually goes on forever. The function doesn't stop when x equals 4. It keeps going on. Let's say she deposits $100. Well, then he would deposit 300. Let's say she deposits 1,000. He would deposit 3,000, and so on. All we've done here is just begun the graph by choosing 5 points and plotting those based upon their values within the formula itself. So we could either leave the points alone as this, or what we could go ahead and do is connect them. Well, if you can visually take a look at this, since we have some graph paper here that has some exact markings on it, you can probably tell visually that this is going to be a straight line. So what I'm going to go ahead and do here is connect these points with a straight line. And this line does continue on indefinitely this way. It doesn't stop here, but for the sake of this demonstration, we'll have it stop. So this then is the graph of a function. And in the particular function we graphed here was y equals 3x. So you should notice a couple things about this function. First of all, the function is a straight line. Second of all, the function intersects the origin. And when we go over here to our final review page, we can see that that's stated here for us. First of all, direct variation. A direct variation is a function whose graph is a straight line which goes through the origin. And then lastly, the basic formula for a direct variation is y equals ax, which means a times x, where x and y are both variables, and a is some constant number other than 0. Well, what would happen if a were 0? Well, a times 0, a for 0, 0 times x would be 0, and y would have to be 0 as well, and it actually ends up corrupting the formula. So a can be any constant number other than the number 0. Okay then, that'll wrap up session 14 on the direct variation.